It's July 2026 and I've got an anniversary to celebrate. No, not that one. 50 years ago I left school with 3 A-levels and no idea at all what I wanted to do as a career. King's College London were foolish enough to offer me a place on a Bachelor of Science Physics degree course, an offer which I readily accepted. And 3 years later I emerged with a degree in physics and a very, very firm idea of what I wanted to do as a career. So let me take you through a few of the items that I've kept since then, and explain how they affected my choice of career. Though not with these guys. We had 2 computing modules during the course. In the first year, basically Fortran programming aimed at physicists. In the third year there was an introduction to microprocessors, and in this case it was the Intel 8080 processor. Now, in order to do some experimenting with the processor, we were introduced to this Altair computer, and basically it provides a front end to the processor itself. These switches and lights are in effect the user interface into the bare wires into the microprocessor. So for example, these 16 switches and these corresponding 16 LEDs, notice they're all red. That was all there was in those days. They map onto the 16-bit address bus of the processor, and here we have the 8 bits of the 8 data bits of the processor. The Intel 8080 is only an 8-bit microprocessor. We have a number of control switches down the bottom, which I mean, obviously we've got off on at the end here. We can stop the microprocessor running or allow it to run. We can, when it's in stop, we can allow it to execute a single instruction. We can examine memory, and we can write data into memory. Not too sure what reset and clear do, or protect, unprotect. The auxiliaries, these 4 buttons we really didn't use. Well, I don't remember using them. So as I say, basically this is a basic user interface into the microprocessor. Now this, I have to say, is merely a mock-up of the front panel of this computer, and in fact it's a project that I started a long time ago and never quite managed to finish. There is a program for the Arduino Mega, which will run this front panel, but I never quite got around to doing it. Maybe someday. So, how do we program this device? Well, the what I've set up is address 0 here. So all of these switches are down. Down is 0. 1 would be up. So for example, that would be address 1. That would be address 2. That would be address 4. That would be address 8. And I'm counting in binary here, so that represents that bit represents the value 1. That is value 2. So that plus that is then 3. And then that is 4. And then 4 plus 1 is 5. And 4 plus 2 is 6. 4 plus 2 plus 1 is 7. And that one is 8. So it's kind of laborious putting numbers in. However, let's take address 0, and I want to write a byte into these LEDs. Now, having set that up, I then click the examine button. That will show the contents of that memory location on these LEDs on the top. I then select the data. So for example, I want to put 10101010 in there, and I press deposit. Note that these switches automatically return back to the central position. So that then will have written that data into that memory location. And that process is to write 1 byte into memory. If I then want to write a byte into the next memory location, so for example, instead of 1010, I want 0101 0101, I can simply click on deposit next. Now that's useful because it automatically advances the memory location, and it writes the data from the switches. So if I then want to go and write all ones into the next location, I set the data up on these lower 8 switches and simply deposit next. And by this means we could enter small programs, because it obviously takes quite a long time to enter them. But this was my first introduction to microcontrollers, microprocessors, and despite the effort of programming it, I just loved it. To the extent that when it came to a final year course project, I chose to simulate this as a major computer program. So let's have a look at what I did there. So I knew this was going to end up as an unboxing video. Right, here is my final year project from 1979, and programming in those days, each line of code was represented by one of these cards, these holograph cards, with the each character represented by holes punched in the card. This line, unfortunately, the ink is faded slightly, So this is calling a subroutine, or it's calling a function in Fortran. My Fortran's a bit rusty these days. The position of the characters on the card is actually quite important. The first column denotes a comment, so I think you had to type a C into that column, and then the rest of the line was treated as simply as a single line of a simple single comment line. I'm afraid you don't find many comments in my code here. It was 1979 and I was at uni. So basically there are two programs in this packet. Unfortunately, the elastic band has perished and stuck to one. So each stack of cards had started with a job slip, which basically told the operators, yes, you had to hand these cards to an operator who operated the computer. The blue slip told the operator who the job was running for, and that's my ID and the priority of the job. Obviously the undergraduate physics students had a much lower job priority than say the PhD students or the professors. Fair enough. And then afterwards we had a job control card which told the computer various parameters about the, come on, focus, the compiler to use, and this is MNF, is Minnesota Fortran, various parameters, and that's the LGO instruction, which is load the program and then go to run it. And there's an end of record there, which tells it that's the end of that section of instructions. And the following module is the program itself. And right at the end you have a statement saying end, and obviously that's the end of that record. And then you have an end of file card, which tells the computer that that's the program loaded and ready to go. Computing in those days was not as simple as it is now. Well, it was simpler in some ways, but it was far more laborious. Each of these cards had to be punched in turn. I'll show you a picture of a card punch in a minute, but obviously what happens if you make a mistake, you've just got to throw the card away and rewrite the card. And that's the program, or that's part of the program. Of course, there's the other part as well. Oh. That was my final year project. Sadly, the ones that I did in my first year didn't really survive. Most of them ended up as shopping list. Must have been some time ago. I see there are 6 sesame buns for 59p. So obviously if you're punching holes in cards and you've only got one chance to do it, you need some way of practicing writing code before you actually sit down to commit the code to the cards. And this is what we use. It's a Fortran coding form. Essentially a piece of paper. You write the lines of code on in pencil, and each line on here represents one card to be punched. And having done that, and having visually checked the code for obvious errors, we used to then go down into a dungeon of a basement down by the Thames in Kings, and the basement itself and the corridors surrounding it were festooned with signs warning what to do in the event of London flooding. Now this was back in the 70s, the days before the Thames barrier was put into place, and so the Thames River flooding over into our basements was a possibility. It never happened, but fortunately it never happened. So what you did was you filled one of these. We went down to the basement. They had a number of IBM 029 card punches. I think it was 029. And we punched the cards. We put them together either in a box or in just held together with an elastic band. Passed them to the operators. The operators would then take them away, and maybe hours later, depending on how busy things were, you end up with your output from the program. Now, this is a program from my first year, and this is the output of the again Minnesota. Oh, this is on a 6600. This was a Control Data Corporation 6600 mainframe computer, and this was a program I wrote in my first year to calculate sunrise and sunset for various times, various dates on various locations on Earth. So in this case, this is London, and gives you some time of sunrise, time of sunset. What's the date? Oh, 19th of June 1066 was a Thursday apparently. Well. But you can see that because of the times involved, debugging of programs was lengthy, should we say. So I think this is the key punch that we used. It's the IBM 029. This page is from Columbia University, and gives more information on the key punch. There's the keyboard layout and the way in which the characters were encoded onto the holes in the card. Here's a better picture of of the key punch. How you used this was to put a stack of blank cards into the top right hand trough, press feed on the keyboard, and a single card would be delivered down into the punch mechanism. Then as you typed the line of code, the card would be moved along character at a time. This box here is does the actual punching. When you're finished typing on that line, you hit feed again. That card is then transferred into the output trough, and another card is fed down into here. So back to the Altair then. As I say, my final year project was to write a simulator for this, and the Intel 8080 processor that sits behind it, and that project actually got me my first job, because I joined a company where they had just developed their own microprocessor, and they needed a simulator so that they could more easily run debugging sessions on their code. And I stayed with them for several years, and I've been involved in software development ever since. So there we are, hopefully a short potted history, and thank you for watching. Hopefully I'll find something less boring for you next time. All the best. Bye.